Have you ever wondered what makes water different from air? Why can we swim in one and breathe in the other? It's a question that sparks curiosity and invites exploration. The answer lies in the very building blocks of these substances. They're molecules. Each molecule, in its unique structure and behavior, holds the secret to the properties that define the substance it forms. In this video, we will embark on an intriguing journey into the microscopic world of molecules. We'll be comparing and contrasting the molecules of two everyday substances we often take for granted, water and air. We'll delve into the structure of these molecules, their interactions, and how these characteristics translate into the properties we experience in our day-to-day lives. So, are you ready to uncover the mysteries that lie in a drop of water and a breath of air? Well, stay tuned as we delve into the fascinating world of molecules and uncover the differences between water and air. To understand the differences between water and air, we first need to understand what molecules are. Molecules are like the building blocks of our universe. Imagine you're playing with a set of colorful building blocks. Each individual block represents an atom, the smallest unit of a chemical element. Now, when you start putting these blocks together, you create all sorts of structures, right? In the world of chemistry, when atoms combine, they form what we call molecules. So, a molecule is simply a group of two or more atoms held together by chemical bonds. Think of it like a team. Each player or atom has their own unique properties. But when they come together to form a team or molecule, they work together, creating something entirely different. And just like in a team, the type of atoms and how they are arranged in a molecule determines its properties. Now let's take a step back for a moment and think about the air we breathe and the water we drink. They're both essential for life, but they are very different, aren't they? That's because the atoms that make up air and water molecules are different, and they are arranged differently. Air is primarily made up of nitrogen and oxygen molecules. Each nitrogen molecule is made up of two nitrogen atoms bonded together, and each oxygen molecule is made up of two oxygen atoms bonded together, and these molecules are free to move around, which is why air is a gas. On the other hand, each water molecule is made up of two hydrogen atoms and one oxygen atom. These atoms are arranged in a specific way that gives water its unique properties, like being a liquid at room temperature. So, you see, understanding molecules is like understanding the blueprints of life. It allows us to see how everything in our world, from the air we breathe to the water we drink, is built from these tiny, invisible building blocks. Now that we know what molecules are, let's explore water and air molecules. Imagine you're a tiny particle floating in a drop of water. What would you see around you? Picture this. You're surrounded by countless others just like you. You're all bonded together, forming a network that spans the entire droplet. You're a water molecule, a combination of two hydrogen atoms and one oxygen atom. This trio is known as H2O, the chemical formula of water. You might be wondering, why does this particular arrangement matter? Well, it's all about the bond. The two hydrogen atoms form an angle with the oxygen atom, creating a bent structure. This gives the water molecule a polar nature, meaning it has a positive side and a negative side. This polarity allows water molecules to attract each other, forming what we call hydrogen bonds. These hydrogen bonds are the secret behind water's unique properties. They're why water can exist in three states: solid, liquid, and gas, at temperatures that are comfortable for life on Earth. It's why water has a high boiling point compared to other molecules of similar size. And it's why water can dissolve so many substances, earning it the title of universal solvent. But that's not all. These hydrogen bonds also give water its surface tension. It's why droplets form. It's why insects can skate on water. And it's why plants can draw water up from their roots. Without this surface tension, life as we know it would be drastically different. These properties of water, its ability to dissolve substances, its high boiling point, its surface tension, they all come down to the humble water molecule. Its unique structure and the bonds it forms are fundamental to life as we know it. The importance of the water molecule cannot be overstated. It's in every cell in our bodies. It covers most of our planet, and it's vital for all known forms of life. So that's the world of water molecules. But what about air? Now imagine you're a tiny particle floating in the air. What's different? In the world of molecules, air is quite the character. It's composed primarily of nitrogen and oxygen molecules, with a smattering of other gases like carbon dioxide, argon, and traces of many others. Nitrogen takes the lion's share with about 78%, while oxygen comes in second with about 21%. The remaining 1% is a cocktail of those other gases. Each of these air molecules is unique. Nitrogen, for instance, consists of two nitrogen atoms tightly bound together. Oxygen, too, is a duo, but with a twist. Its two atoms share electrons, creating a double bond that gives it its unique properties. Now here's where things get interesting. Air is a gas, meaning its molecules are free to move about, bouncing off each other and the walls of their container. This constant motion, this ceaseless dance, is what gives air its ability to fill any space available to it. It's why, no matter how big a balloon you have, air can fill it up. Air molecules are also responsible for the pressure we feel. When you're at sea level, you're experiencing the weight of all the air molecules above you pressing down. It's like a molecular blanket wrapping you in its invisible embrace. But air isn't just about pressure and volume. Its molecular structure allows it to do some amazing things. For instance, oxygen is vital for life. It's what we breathe in to keep our bodies running. Nitrogen, on the other hand, is essential for plants, helping them create the proteins they need to grow. And let's not forget about carbon dioxide. This molecule, made of one carbon atom and two oxygen atoms, plays a crucial role in photosynthesis, allowing plants to convert sunlight into food. So you see, air molecules are more than just tiny particles floating around. They're the unsung heroes of our atmosphere, working tirelessly to maintain the balance of life on Earth. And that, dear viewers, is how air molecules differ from water molecules. So, we've taken a journey into the world of water and air molecules. We've delved into the fascinating world of molecules, the building blocks of everything around us. They may be tiny, but their impact is monumental. They define the properties of the substances we interact with every day, including water and air. Starting with water molecules, we learned that they are composed of two hydrogen atoms bonded to one oxygen atom, forming a V shape. This unique structure results in a polar molecule, meaning it has a positive side and a negative side. This polarity leads to the phenomenon of hydrogen bonding, which is responsible for many of water's unique characteristics. It results in water's high surface tension, which allows certain insects to skate on a pond surface, and its ability to dissolve many substances, earning it the title of the universal solvent. Moreover, we discussed how water's molecular structure leads to its unique behavior when it freezes. Unlike most substances, water expands when it freezes, which is why ice floats in liquid water. This is because the hydrogen bonds align to form a hexagonal structure, creating more space between the molecules. Switching gears to air molecules, we discovered that air is a mixture of several gases, primarily nitrogen and oxygen, with small amounts of argon, carbon dioxide, and other trace gases. These molecules are far apart and move freely, resulting in the characteristics we associate with gases. They fill their containers, can be easily compressed, and have low densities. Unlike water molecules, air molecules are non-polar. They don't have a positive or negative side, and thus don't form hydrogen bonds. This means they don't have the same cohesive properties as water, which is why air doesn't behave like a liquid or a solid. In essence, the main difference between water and air molecules lies in their structure and the bonds they form. Water's polar nature and ability to form hydrogen bonds lead to its unique properties, while air's non-polar molecules and lack of hydrogen bonding result in its gas-like behavior. In conclusion, Our everyday experiences of water and air are determined by the tiny, invisible molecules they are made of. The world of molecules is a fascinating one, filled with intricate structures and behaviors that shape our world in ways we often don't realize. Thanks for joining us on this molecular journey. Remember, even the things we take for granted, like water and air, have their own fascinating stories at the molecular level.